Hello friends and welcome to Geeks for Geeks. In this video, we are going to learn in-order traversal in trees without the use of recursion. Before we begin, let's have a quick review of in-order traversal. In in-order technique, we first traverse the left subtree, then we visit the root node and then the right subtree. Let's see it with an example. Here is a sample tree. We start from root node A, go to its left subtree B. Once at B, we again go to its left subtree, which is D. We now check left of D, which is null, so we come back and print D. Then check right subtree of D, which is again null, so we return to B. Since left subtree of node B is over, we print it and go to its right node, which is E. We then do a similar process, go to F, print F, come back to E, print it, and move to node A. Now left subtree of node A is done and we can print this node. Now the right subtree need to be traversed. We come to node C, no left subtree found, so print it, and since there is no right subtree, the algorithm finishes. For those of you who need a more detailed explanation, can see a separate video we have made on tree traversals. Now we have a brief idea of the task required to be done. This seems quite easy to implement if a recursive method was allowed, but we need to do it without recursion. Think about a data structure which behaves similar to recursion. A stack? Yes, after all, what is a recursive method really doing under the hood but implicitly making use of the call stack? Let's look at an algorithm that uses stack to perform in-order traversal. These 5 steps will be sufficient to perform our task. Notice that we are making the use of a stack. Let's take a sample tree. We begin with step 1 and create an empty stack. Next, we create a variable current and initialize it with the root node. Here our root node is A. In third step, we pushes the current node to our stack, set current variable to point to its left node, and keep doing this until our current node is not null. So we push A into the stack, make current to point to the left of A, which is B. Again, current is not null. We push current node into stack and make current to point to the left of B, which is D. Again, current is not null. We again push current node into stack and make current to point to the left of D, which is null. Now current is null. Now we go to step 4, and since current is null and our stack is not empty, we do the following. We pop the top of stack and print it. Here it is D, so we pop it and print it. Now we set the current variable to point to the right of the popped node. Since right of D is null, our current variable remains null. Now we go to step 3. Since current is null, step 3 doesn't do anything. We come to step 4, and since current is null and stack is not empty, we pop the top of stack and print it. So here we pop and print B. Next, we set current to point to the right of B, which is E. We go to step 3. We push E to the stack and make current to point to the left of E, which is F. Since current is not null, we push current to the stack and make current to point to the left of F, which is null. Now since current is null, we go to step 4. Current is null and stack is not empty. We therefore pop the top of the stack and print it. We print F. Now make current to point to the right of F, which is null. We now go to step 3. Since current is null, step 3 doesn't do anything. We come to step 4, and since stack is not empty, we pop and print the top of our stack, which is E. Now we make current to point to the right of E, which is null. We now go to step 3. Since current is null, step 3 doesn't do anything. We come to step 4, and since stack is not empty, we pop and print the top of our stack, which is A. Now we make current to point to the right of A, which is C. We now go to step 3, push C into our stack and make current to point to the left of C, which is null. We go to step 4. Since current is null and stack is not empty, we pop and print the top of stack, which is C, and make current to point to the right of C, which is null. We go to step 3, and since current is null, step 3 doesn't do anything. We go to step 4, and since current is null and stack is empty, this step also doesn't do anything. We go to step 5, and since current is null and stack is empty, we are done and we terminate. So this is how our in-order traversal will look like, and this is the same as we have obtained from our recursive approach. Let's look at an implementation code. This is a C language implementation which is taken from Geeks4Geeks. Notice here we also have to implement our own stack, which is not shown in this image. Next, we move on to the complexity of this code. Since the algorithm is running in linear time, the time complexity will be big O of n, where n are the number of nodes in our tree. With this, it's time to wrap up this tutorial. If you have any doubts or suggestions, please leave them in the comment section below. Thanks for watching.